August 1942. Alaska-Canada Highway, 3 in the morning. Freezing muskeg swamp stretching into darkness. A LeTourneau Carryall scraper has been running 11 hours straight. The operator is Private Ray Donnelly, 22 years old, from a small town in Ohio. At 3:47 a.m., the main bowl cable snaps. 1,800 pounds of steel drops in 0.3 of a second. The Army lists cause of death as equipment malfunction. They do not mention the cable was flagged for replacement 3 weeks earlier. They do not mention 7 other operators died the same way that summer. They bury Donnelly beside the road. They keep building. They finish the highway in 8 months. These are 10 scrapers from the 1940s that killed operators before hydraulics changed everything. We are starting at number 10 and working down to the machine that killed people with the one technology that was supposed to save them. Before we get into the machines, we need to understand what a cable scraper actually does. A scraper is a giant steel bowl on wheels. The bowl cuts into earth, fills with dirt, and the operator drives to a dump location and releases the load. Simple concept. The problem in the 1940s was how that bowl got raised and lowered. On a cable scraper, a single steel cable wrapped around a winch drum controlled everything. One drum, one cable, zero margin for error. The operator turned a lever, the drum rotated, the cable spooled in or out, and the bowl moved. Hydraulic systems respond instantly and hold position under load. Cable drums could overwind, snap under tension, or two blocking. Two blocking means the drum hits its mechanical stop while the cable is still under load. The bowl does not slow down. It drops instantly. 1,800 pounds of steel at gravity speed. In the 1940s, cable scrapers were everywhere. The ALCAN Highway carved 1,700 miles through permafrost in 8 months. Pacific airfields at Leyte Gulf, Okinawa, and Bougainville were built on scrapers in 130-degree heat. Every post-war suburb started with a cable scraper cutting raw earth. One man designed 70% of them, R.G. LeTourneau, 6th grade dropout who left school at 14, no engineering degree. By 1942, his factories produced 10,000 Carryall scrapers, 14,000 bulldozer blades, and 1,800 Tournapulls. Before the Tournapull, scraper cycles required 3 men: tractor driver, blade operator walking alongside the machine, third man coordinating loads. Productivity was 40 cubic yards per day. European engineers published papers declaring single-operator scraping mechanically unsound. LeTourneau did not read those papers. He built the single-operator Tournapull anyway and shipped thousands to construction sites across 2 continents. The scale of cable scraper deployment in the 1940s is difficult to comprehend today. Every military airfield in the Pacific was built by cable scrapers. Every mile of the ALCAN Highway was cut by cable scrapers. Every post-war housing development from Levittown to the suburbs of Los Angeles started with cable scrapers moving millions of cubic yards of earth. These machines ran around the clock. Operators worked double shifts in conditions that would shut down modern sites immediately. There were no safety regulations. There were no mandated inspections. There was only production quotas and deadlines, and men who needed paychecks badly enough to climb into machines everyone knew were dangerous. The death rate was considered acceptable. That was the term in official reports. Acceptable losses for the pace of construction required. The men who died were replaced. The machines kept running. The cables kept snapping. And the number 1 machine on this list killed operators with the one technology that was supposed to save them. Number 10. The LeTourneau Carryall Model LW was built from 1938 to 1948. It was the first mass-produced cable bowl scraper in history. The bowl raised and lowered on a single cable over a winch drum behind the operator's seat. The primary failure was 2 blocking under load. When the operator pulled the lever to raise a full bowl, The drum rotated and spooled cable in. If the operator held the lever too long, or if the mechanism stuck, the cable kept spooling until it hit the stop. All tension transferred to the bowl attachment points. The bowl then dropped straight down. On the ALCAN Highway in 1942, 14 operators died from cable failures in 8 months. 14 deaths from one failure mode on one project. The cables were rated for the loads. The drums were machined to spec. It just was not built safely. One survivor wrote that the cable gave no warning. One rotation too many, and the drum locked. He heard the snap before he felt the impact. He went back to work the next morning. There was no other option. The Carryall established patterns that would repeat across the cable scraper industry for 15 years. Single-point cable failure, inadequate operator protection, and production schedules prioritizing speed over safety. LeTourneau's factories ran 3 shifts producing Carryalls throughout the war. Quality control existed on paper. In practice, cables were installed as fast as they could be manufactured. When a cable failed in the field, there was rarely any way to trace it back to a specific batch or identify a systemic problem. The ALCAN Highway became an unofficial testing ground for cable scraper reliability. Temperatures dropped to 40 below zero. Mud froze solid overnight and thawed into bottomless muck by afternoon. Cables that might have lasted months in normal conditions failed within weeks. But the Carryall was just the beginning of LeTourneau's cable empire. Number 9 had even more cables to fail. Number 9. The Wooldridge Carry-All, built from 1940 to 1950. Towed behind Caterpillar D6 and D7 tractors. Where LeTourneau used one cable, Wooldridge used 3 cables to control the bowl, apron, and ejector separately. 3 cables meant 3 failure points. But that was not what killed most Wooldridge operators. Push loading did. A towed scraper cannot dig hard earth alone. It needs a bulldozer pushing from behind. Dozer and scraper operators worked within 18 inches of each other. No radio communication. The dozer operator signaled with a horn. 1 blast meant push, 2 meant stop. When the bowl was full, the dozer operator could not see it. He was staring at the back of the scraper cab. He had to trust that the signal came in time. On the ALCAN Highway, push-loading collisions killed 9 operators from 1942 to 1943. 9 men were crushed because a horn signal arrived half a second late. Operator Fred Arnold wrote in 1944 that he preferred the Wooldridge because he understood the cables. He could predict their failures. He could not predict what the man behind him would do. That kept him awake at night. The push-loading problem was fundamentally unsolvable with 1940s technology. Radios existed, but they were not provided to operators. Visual signals were impossible when the dozer operator could not see past the scraper cab. The horn system was the best available option, and it killed men regularly. Wooldridge had a communication problem. LeTourneau's self-propelled version had a different problem entirely. Number 8. The LeTourneau Tournapull Model A. Built from 1938 to 1946. The first self-propelled cable scraper in history. No towing tractor, no push dozer, 1 machine, 1 operator. LeTourneau designed it in a hospital bed while recovering from a car accident. He had a broken pelvis and nothing to do but sketch machines. The tires he needed did not exist. So he called Goodyear and told them to invent them. They did. When he showed blueprints to Caterpillar, their engineers said the single-axle design was not feasible. It would jackknife on any slope over 8 degrees. LeTourneau was their largest supplier. He listened. He built it anyway. 2 years later, they parted permanently. The engineers were right. The Tournapull did jackknife. On side slopes, 40,000 pounds wanted to fold around its pivot point. Operators fought the steering wheel against physics. When jackknife happened, it was binary. If the upper joint failed, the operator flew forward through the windscreen. If the lower joint failed, the bowl contents buried him in the cab. Rollover rate was 1 per 340 operating hours. No rollover protection existed. ROPS were not yet invented. When a Tournapull went over, the operator had nothing between his head and the ground. Operators called it the widow maker. LeTourneau called it his greatest achievement. Both were correct. The Tournapull created a new category of accidents. Towed scrapers killed through cable failures and push-loading collisions. Self-propelled scrapers added rollover deaths and jackknife fatalities. LeTourneau continued improving the design, despite the death toll. Each model addressed some problems while creating others. The Model B had better weight distribution, but weaker joints. The Model C had stronger joints, but a higher center of gravity. Every solution created new failure modes. Operators developed informal survival techniques. They learned to read terrain and predict jackknife. They shared information about which machines had stability problems. None of it was official or documented. It was knowledge passed between men who wanted to survive. Self-propelled was supposed to be safer. It was not. Number 7. The Caterpillar. Number 70. Cable scraper. Built from 1941 to 1952, it was towed behind D7 and D8 tractors. Its bowl ran on cables similar to the Carryall. The problem was not the bowl. The scraper had no brakes. No independent brakes whatsoever. Number 70 weighed 40,000 pounds when loaded. It connected to the tractor through a drawbar. The tractor had brakes. The scraper did not. On a downgrade, the full weight pushed against the tractor. If the drawbar failed, 40,000 pounds became an uncontrolled projectile. In California in 1947, a Cat D8 was working a 12-degree slope. The drawbar cracked at the hitch. The scraper overran the tractor in 3 seconds. The operator did not have time to jump. Investigators found the D8 20 feet down the slope, with number 70 on top of the crushed cab. Number 70 had 2 failure points, the cable that controlled the bowl and the connection that kept the rig together. Either could kill you. The combination of unbraked weight and cable controls made it particularly deadly on any terrain that was not perfectly flat. Number 6 was dangerous because of what closed it. Number 6. The LeTourneau Gondola series, built from 1942 to 1950, named for the curved bowl shape. These machines built the Pacific airfields at Leyte Gulf, Bougainville, and Okinawa. Every runway that launched B-29 bombers started with gondola scrapers. The gondola had 2 cables, a main cable for the bowl and a secondary cable for the apron, the front door. The operator monitored both simultaneously. When the apron cable wore through, it did not fall open. It slammed shut, 2,200 pounds swinging like a guillotine. If the operator had his arm extended past the cab edge, the apron took it. Leyte Gulf, 1944. 3 operators died from apron slam. Heat accelerated cable wear. Coral dust contaminated lubrication. Operators worked 16-hour shifts in 130-degree cabs, monitoring 2 drums while sweat pooled beneath their seats. The Pacific Theater pushed cable scrapers beyond their design limits. Heat degraded every component faster than engineers had predicted. Coral was more abrasive than any soil condition tested stateside. Maintenance schedules designed for temperate climates were meaningless in the tropics. Every Pacific runway had a price. If you want to see what was running alongside these scrapers on every 1940s job site, the 1940s Bulldozers episode is in the description. Over 11,000 people have watched it. But stay here, because we are getting into the machines that worked in tandem with those bulldozers. Number 5 is where things get genuinely brutal. Number 5. The LeTourneau Mountain Mover, also called the Tournarocker, was built from 1944 to 1952. It was the largest cable scraper of the 1940s, with a 40-ton bowl capacity. The mountain mover required 2 cable drums at the same time, one for the bowl and one for the apron. Each drum had its own lever, and each had its own failure mode. Every failure that could happen on other machines applied to both systems at once. This was a dual-drum machine. The 2-blocking risk doubled. The bowl cable could 2-block. The apron cable could 2-block. Both could fail at the same time. A single operator controlled 4 cable movements with 2 hands, while driving a machine heavier than a loaded semi. An operator later said 6 hands were needed to run it safely. You only had 2. Operators learned to sequence movements: bowl down, apron open, load, apron close, bowl up. Any mistake, and the cables reminded you what physics meant. The mountain mover was too much machine for any single operator to control safely, but it moved more earth per cycle than any other scraper available. Contractors kept buying them, and operators kept dying on them. California highway construction, from 1945 to 1952, saw 23 deaths linked to mountain mover cable failures. The mountain mover was the biggest. Number 4 was supposed to replace it. Number 4, the Caterpillar DW10 and DW15, built from 1946 to 1955. Caterpillar's motor scraper after splitting from LeTourneau. Cat built the tractor. LeTourneau supplied the cable bowl. That combination was the problem. Caterpillar designed the tractor frame with hydraulic provisions built in. They knew hydraulics were coming. They had been testing since 1944. But they had contracts, and LeTourneau had cable bowls in warehouses. So Cat bolted a modern tractor to an obsolete bowl. The DW10 looked modern, updated cab, newest diesel. Everything about the tractor said 1950s technology. The bowl ran on 1938 cable technology. Operators assumed the machine was modern because the tractor felt modern. That false confidence killed them. They pushed cables past design limits. The DW10 cable failure rate was 340% higher than matched systems. The DW series represented everything wrong with the transition period between cable and hydraulic technology. Companies knew better systems existed. They sold obsolete equipment anyway because inventory had to move and contracts had to be honored. Caterpillar knew hydraulics were coming. They had not committed yet. Number 3, the LeTourneau Super C, built from 1943 to 1951. The most produced cable scraper in history. Over 25,000 units. One factory, one design. Mass production created inconsistent cable quality. Building 100 scrapers, you inspect every cable. Building 25,000, quality control means sampling. Some machines left the factory with failure built in. Cab temperatures reached 130 degrees with zero ventilation. Operators in 8-hour shifts made mistakes they would never make in reasonable conditions. Dehydration affected judgment. Heat exhaustion slowed reaction times. Deep mud created a failure cascade. A bowl cut of saturated clay weighing 3 times dry earth overloaded the cable. The drum could not stop before 2-blocking. An exhausted operator could not react in time. 25,000 units meant 25,000 daily opportunities for the same failure. While this happened, LeTourneau gave away 90% of his earnings. He stood at a church pulpit in East Texas and said he shoveled money out, and God shoveled it back. God had a bigger shovel. The man who built the deadliest scrapers was funding missionary schools in Peru and hospitals in Liberia. That makes no sense. It is completely true. LeTourneau genuinely believed he was doing holy work by building earth-moving equipment. He also built machines that killed hundreds of operators and resisted safety improvements for years. People are complicated. History is messy. The machines kept killing regardless of intentions. We are in the top 2. If you have not seen the 1940s Bulldozers episode, it is in the description. The bulldozer pushed, the scraper loaded. They killed operators in completely different ways. Number 2 shows what happened when those machines worked together, 18 inches apart, with nothing but a horn between life and death. Number 2, the LeTourneau Tournatractor with pusher system, built from 1945 to 1955. First coordinated push-pull system, Tournatractor scraper plus dedicated push dozer. 2 machines, 2 operators, 1 cycle requiring perfect timing. Tournatractor scrapers were larger than Tournapulls. They needed help cutting hard ground. LeTourneau designed a system where a dozer pushed during loading. Production doubled. 2 men who could not see or hear each other coordinated within 18 inches at walking speed. The dozer operator signaled with a horn. 1 blast meant push, 2 blasts meant stop. That was the entire communication system. The push blade sat 18 inches from the scraper cab. When pushing, the scraper operator felt impact through his seat. He could not see the dozer operator's face. He trusted that when he signaled stop, the man behind would react in time. The documented collision rate was 1 serious injury per 14 operating days. Every 2 weeks, someone got caught between blade and cab. Injuries ranged from broken ribs to crushed spines to deaths listed as equipment malfunction. An operator testified years later, "You trusted the man behind you with your life." Every load. Some days you worked with the same partner for months and learned his timing. Other days you got a replacement who had never pushed a Tournatractor, and you wondered if today was the day the horn did not work. Trust was everything. The pusher system represented the peak of coordinated cable scraper operation. It was also the peak of danger. 2 massive machines working in perfect sync with no real communication between operators. 2 operators, 0 communication beyond horns. That was number 2. Number 1 tried to solve every problem on this list at once. Every machine we discussed shares one root cause: cables. Steel cables on drums could overwind, snap, two-block, or wear through. LeTourneau knew it since 1938. In the mid-1940s, while factories still produced cable scrapers, he designed something different. Electric motors in each wheel. No drums, no cables, no two-blocking. Bowl raised through electric actuators with instant response. By 1946, he had a working prototype. He was 57. He had spent 43 years watching cables fail. He called it his greatest invention. His operators had a different description. Number 1, the LeTourneau electric wheel scraper prototype, tested from 1946 to 1953. Electric motors in each wheel. No transmission, no cables, pure electric drive. On paper, it solved everything. No cables meant no two-blocking. Electric motors held position without linkages. Bowl raised at a button push with instant response. LeTourneau was 57 when he built the first prototype in Longview, Texas. He personally supervised every weld. He had waited a decade to build this machine. The fatal flaw was water. Earthmoving happens wet, rain, mud, standing water. Prototypes had uninsulated electrical connections to wheel motors. When water intruded into high-voltage housings, results were not what drawings predicted. A shorted wheel motor did not stop. It accelerated in the wrong direction. When a motor shorted, the affected wheel spun at maximum speed in whatever direction the short dictated. Complete loss of directional control. 40,000 pounds wanted to turn hard left or right at full power. Nothing could overcome a motor at full current. 3 test operators died during prototype trials between 1946 and 1948. 3 men in Longview who believed they were testing the future. LeTourneau classified incidents as testing accidents. No compensation to families. No announcement. Reports sealed. Technology abandoned for over a decade. When the electric wheel returned in the 1960s, engineers redesigned from scratch. They did not know LeTourneau's prototype had failed. They solved insulation independently. Modern electric scrapers descend from that redesign. The 3 deaths represent one of the most closely guarded secrets in earth-moving history. LeTourneau's companies never acknowledged the fatalities. Industry publications never reported them. Families signed agreements preventing discussion. The insulation problem was solvable. Engineers in the 1960s proved that. Better materials existed. Better sealing techniques were available. LeTourneau simply did not take the time to implement them before putting operators in the machines. The operators who died testing his version are not commemorated anywhere. No memorial, no history book. They exist only in a classified report never made public. LeTourneau went to his grave in 1969, calling the electric wheel his greatest achievement. He was 80, still drawing plans in his final months. 3 men went to their graves, proving why that achievement was not ready. Between 1940 and 1955, an estimated 1,800 American operators died on cable scrapers. Military construction, civilian highways, post-war housing. 1,800 men who left for work and did not come home. Cable failures caused 40%, 720 men. Push-loading collisions caused 25%. Rollovers without protection caused 20%. Bowl and apron failures caused 10%. Heat, drowning, and fires caused the rest. LeTourneau's scale is staggering. 4 years of World War II, one factory produced 10,000 carryalls, 14,000 bulldozer blades, 1,800 Tournapulls, 1,600 sheepfoot rollers. One man's designs. 6th grade education. Converting the Super C fleet to hydraulics in 1955 would have cost $12,000 per machine. 25,000 machines. $300 million total. LeTourneau resisted for years. Cable control was his invention. He owned the patent. He had built his empire on it. In 1953, LeTourneau sold his earth-moving operation to Westinghouse. He was 65. Most men retire. LeTourneau started over. New company, new machines, new attempts at the electric wheel that had killed 3 operators. He kept working until he died in 1969 at 80, still drawing plans in his final weeks. He genuinely could not stop. The transition from cable to hydraulics happened gradually through the 1950s and the 1960s. There was no single moment when the industry decided cables were too dangerous, and there was no regulatory mandate. It was slow recognition that hydraulics were more reliable and less likely to kill operators. By 1970, cable scrapers had disappeared from American sites. A few survived in developing countries. Most were scrapped for steel. Today, a working 1940s cable scraper is a museum piece. The scrapers of today have hydraulic bowls, electronic controls, and safety systems that would have seemed like science fiction in 1945. Those machines exist because 1,800 men figured out why cables were not enough. That history has no monument. It has a body count. Remember that. These were the most brutal scrapers from the 1940s. Want to see what replaced them? Click the video on screen and watch the world's biggest scrapers of 2026. The distance between these 2 eras will blow your mind.